Right. Now, we are in unit 2. This last week we spoke about hybridized orbitals and unhybridized orbital. Just chuttak, I will recall that. Everyone having the idea of the s orbital and the p orbital? What is the... No? No problem. If you didn't get, I'll give you, right? Where everyone have the idea of s orbital and the p orbital, right? So in the s orbital and the p orbital, what is the shape of the s orbital? Spherical shape. What is the shape of the p orbital? Dumbbell shape, right? Okay. Then s orbital is spherical shape like this. P orbital is what shape? Dumbbell shape like this. Okay. So I told when these things, when these sp orbital, when they are going to make some bonds, what they do before they make bonds, they hybridize. They hybridize S and P get together. So in this tute, check the last online students. Okay, you can see the students. I will say other tute in the chat box. You all can see that, right? I'll share the tute in the chat box. Online students can download it, and you can check that. Who have got the tutes, you all check the last page. Okay, check the last page. The last page, Puta, you got, right? Okay. Online students, I have sent, check whether you have received it. Okay, I hope you would have got it. Okay, it's in the chat box. Got it, right? Right. Now, so you can see here, how when 1s and 1p, when it join, what is the shape of it? Clearly, you can see. Okay. Again, now these S and P joining together, when 1s and 1p join mean, you can see the shape of this is like this. Again, this even shape, it will lose its even shape. It will lose its even shape. This is the nucleus mean. One is like this, other one is tuck like this. Okay. So when this is sp, when it comes to sp2, what happens? Can you see that? When it comes to sp2, it is like this. Then tuck, it will even reduce than this. Then if it comes to sp3, it is like this. This will be even smaller. This is sp3. Okay, again now you can see this is S and P. When it hybridize, it will take a fish-like shape. Okay, so when you see a picture, you should understand whether these things are known as unhybridized orbital. Unhybridized orbital. Unhybridized orbital means these are in pure format. Pure format means this is only S orbital, this is only P orbital. Those are in the pure format. So when it hybridize, what happens? When S and P joins together, there we got, okay, some chuttak, what will happen? These shapes will change like this. Okay. So these shapes will change. So when the P character increases, P character means these 1p, these 2p's, these 3p's are here. When the P character increasing, what's happening to this size? It is reducing. So with that, you can realize what type of hybridization it is. These things we have already done. Poddak, I'm recalling the things, right? So remember, if it known as sp hybridized mean, how many sp hybridized orbitals will be there? How many sp hybridized orbitals will be there? If it sp2 mean, how many sp2 hybridized orbitals will be there? If it sp3 mean, how many sp3 hybridized orbitals will be there? Do you have any idea? Right? Normally sp mean, you can see sp hybridization mean 1s and 1p has joined. Then altogether how many numbers are there? 2. There are 2. Here 1s and 2p's are there. Then altogether 3. Then there are 3 hybridized orbitals in this. Here 1s and p3 mean altogether 4. Then there are 4 sp3 hybridized orbitals are there. That's how you see these things, right? So actually, these things we don't give that much importance, but this is to just to know this, because this sp3 hybridization and all you should know properly, right? Because today main topic is with this hybridization, we are going to see the molecular shapes, right? We are going to see the molecular shapes. Then, if you go like this, last week we drew. If you are much aware about this, good. Last week we drew how to draw for CH3. CH3. I spoke how to draw for this. Then I said how to check the hybridization. How to check the hybridization, guys? It is how many s orbitals are there? Normally, one s orbital has only one orbital. In P, how many orbitals are there? P has 3 orbitals. What are those? They are P1, P2, P3. There are 3 p orbitals. And how many d orbitals are there? There are 5 d orbitals. There are 5 d orbitals. Everyone knows this, no? Yeah. Right. There are 5 d orbitals. Right. Now it means there are 1 s orbital, 3 p orbitals, and 5 d orbitals. Now, how to check the hybridization, guys? You have to check the hybridization with sigma bonds and lone pairs. Do you all know what is sigma bonds? Last week I taught sigma bonds. You all know sigma bonds? You all know pi bonds? Don't know, right? Then I'll explain that part also. It means if you take any bond, this is a product more idea than this. At the moment, just you know this thing like this, that is okay at the moment. We'll say carbon-carbon has a double bond. We'll say carbon-carbon single bond, carbon-carbon triple bond. Now, if I say in the carbon-carbon single bond, if I ask how many sigma bonds are there, I mean, you will answer 1 sigma bond. In carbon-carbon double bond, how many sigma bonds are there? I mean, you will tell, this is the meaning of this sigma symbol. There is only 1 sigma bond. And the other bond is a pi bond. Then other bond is a pi bond. Here, then how many sigma bonds will be in this? 1 sigma bond. Always only 1 bond is sigma bond. So we say this is 1 sigma bond. And how many pi bonds are here? There are 2 pi bonds in this. Then 1 sigma bond and 2 pi bonds. Okay. So between an atom, between 2 atoms, what is the maximum number of bonds they can make between 2 atoms? Guys, speak. What is the maximum number of bonds they can make between 2 atoms? 3. Very good. They can make maximum 3. Maximum 3 means out of that, then what is the maximum number of pi bonds they can make? Only maximum 2 pi bonds. What is the maximum number of sigma bonds they can make between 2 atoms? Only 1 sigma bond. Okay, so you get the idea of this. So when we are checking the hybridization, guys, hybridization we check. Hybridization we check. I guess we wrote these things no in our class. We wrote these things, right? How to check hybridization now? In hybridization, this is just for recalling for the students who came today. Okay, hybridization mean, guys, right? Remember, you have to see how many sigma bonds are there. Number of sigma bonds. You have to check how many sigma bonds are there. You have to check how many lone pair electrons are there. You have to check how many lone pairs are there. You have to check the number of lone pairs as well. Okay, if you want to check the hybridization, you have to check the lone pairs and the sigma bonds. For example, now I will draw certain things and I will show the hybridization of these things, right? You have written these things to hybridization. Right. If for the students who came today, if you want to note anything related to this, Taggala, you can note it down if you want to note anything. Right. Again, now no need to mark these things at the moment. If you want to note any other thing other than this, right? If you want to mark any other thing other than this, you can mark. Again, out of these things, hybridization are checked by sigma bond and hybridization are checked by lone pairs. Then what is sigma bond, what is pi bond, just have an idea. Last week we explained this one in detail, so you can check that in case if you want. Right. Because today we have developed today's lesson. Today's lesson is very interesting, right? So without these things, it will what will happen? Or it will be difficult to you. Set right? I guess if you stay there, you won't be able to see the board clearly. So come here, come to this corner. And Putha, don't fight Putha like it's small kids, right? Come here. Okay, right? Okay. Now, guys, we'll see. Let's check. Okay, today we will do this question, and today itself we will do questions, short questions related to this from the past papers. I think we are done with this, right? So we are almost last part of this lesson. With this lesson, we are almost done with unit 2. Then we have only a secondary interaction kind of article will remain. One day we can finish, right? Then unit 2 done. Okay, unit 3 already we are doing as chemical calculation nights. Then we can start the unit 3 freshly, right? Now, Bhuta, I will draw few molecules and I will show you. We'll think H2O. Everywhere, whenever we go, first thing is H2O. Right? Taggal, I will show you the hybridization of these things, right? I'll take H2O like this, to draw H2O. We'll draw like this. This is H2O. Now they will ask what is the hybridization of the hydrogen. Now we have S, think with this, S, 3p and 5Ds are there. Now they will ask you, tell the hybridization of hydrogen. If they ask to tell the hybridization of hydrogen, right? Hybridization of this hydrogen. How many sigma bonds hydrogen has? Hydrogen has how many sigma bonds? This hydrogen has only one sigma bond, because only one bond mean that is the sigma bond. Then one sigma bond mean it will hybridize only with one thing. It's what we say. This is oneness hybridization. Especially for hydrogen mean don't just put S hybridization. You have to put oneness hybridization, because hydrogen belong to first period. So we say oneness hybridization. Then this hydrogen, how many sigma bonds it has? Only one sigma bond. Therefore, we say what is the hybridization? Oneness hybridization. So I put oneness for this. Great. Now tell me for this oxygen, guys, how many sigma bonds are there for this oxygen? Carefully open your eyes and see how many sigma bonds are there. Can you see there are two sigma bonds? This oxygen is connected with this and this. There are how many sigma bonds? Two sigma bonds are there. Okay, ne? If not okay, right? There are two sigma bonds. Then this oxygen has two sigma bonds. Tell me how many lone pairs are there for oxygen? How many lone pairs? You know what is a pair, right? When two things get together, that's a pair. Then how many pairs are here? 1, 2. Then lone pairs 2. Then altogether, how many things are involved? 4 things are involved. Then 4 things are involved in 1, 2, 3, 4. Then what is hybridization? sp. The hybridization is this oxygen has sp3 hybridization. Now, did you understand how to write this hybridization? Is it clear? Anyone has any doubt in hybridization? Some people like we understood, but like not sure. Okay, kind of state or between understanding and confusion. Okay, you'll understand everything very clearly with this. Okay, we'll go for another one. We'll think something like C, Cl, CCl4. Natang CHCl3. We'll think something like CHCl3. Okay, CHCl3. Right. Now let's check the hybridization of these things. Now you have to, when you're marking, or you have to draw the electron. There is a Lewis structure for this. First of all, you have to draw the Lewis structure, right? Everything correct? Now, I'm not training you to draw Lewis structures now. That's not my part today, right? So CHCl3, we'll check the carbons I'll put the atoms, carbon, chlorine, hydrogen, because all chlorines are same. So I'm going to write the hybridization. Tell me, in this carbon, how many sigma bonds are there? Okay, you just predict. What are the hybridization skills? You just predict. What should be the hybridization of hydrogen, carbon, and chlorine? You just predict. Don't tell the answers. Just keep it in your heart. Don't tell what is it. Okay. I hope you would have done this. Right. Okay, no? Okay or no? You are telling yes or no? You didn't do it. Okay, no problem. Who did? Who have some ideas? Okay, now let's check. Now tell me, around this carbon, how many sigma bonds are there? Raggal answer. Answer. The answer. You can see, you know, how many sigma bonds are there? How many? 4, right. Then 4 sigma bonds mean, guys, what is hybridization? 4 sigma bonds are there. I mean, 4 things should join together with these orbitals. There 1s, I said, no, this is the connection. 1s, then 3p, there are 5d. Then sp3. So the carbon's hybridization is sp3 because I can say there are 4 sigma bonds. There are 4 sigma bonds. The hybridization is what? sp3. Okay. Now tell me for the chlorine. Chlorine, how many sigma bonds are there? 1 sigma bond. And when we are checking the hybridization, we check the sigma bonds and lone pairs. How many lone pairs are there? 3 lone pairs. Then sigma bond 1, lone pairs 3. Altogether, how many are there? 4. Altogether, there are 4. So we say, what is the hybridization of this? sp3. 4 mean sp3. 4 mean 4 orbitals are involved to make this. Then we say the hybridization is sp3. Is it clear now? Good. Tell me what is the hydrogen's, this one. Hydrogen has only 1 sigma bond. If it has only 1 sigma bond, what is the hybridization, guys? 1s. Don't tell just s. If you tell just s, we don't accept it. There you have to tell it's belong to which period. You have to say hydrogen is in the first period. So this is 1s. So when more than one thing is joined, for these things we call hybridized orbital, HO. This is also hybridized orbital. When they don't connect with any other thing, when they are alone, we call them as, okay, atomic orbital. One is what orbital? Atomic orbital. So understand these words, hybridized orbital and the atomic orbital. I hope you all clear. Right? Right. This is the first example I gave about H2O. This is the second example I gave about CHCl3. This is the third one. I will give you something like this. Okay. Do you know who is this? Do you know this name? This is hydrogen cyanide. Okay. So no need to know those things at the moment. Later, but you will know this. Now there is a thing called HCN. Now I want the hybridization of hydrogen and this carbon and this nitrogen. You just think, what should be the hybridization of hydrogen, carbon, and nitrogen? I will give time to write these things, Buddha. At the moment, first of all, we'll have a conversation and you build up things and you just think, this is this, this is this, this is this, right? Okay. I hope you would have got the answers. Got right? Get it. Hydrogen. Wherever hydrogen comes, always it is what? Oneness. Wherever hydrogen comes, always it is oneness. I no need to check that. Always hydrogen can bond with only 1 sigma bond. Other than that, hydrogen can't bond with any other way. Right, great. Then carbon. When we come to carbon, Buddha, so carbon is bonded with how many sigma bonds? 4 sigma bonds. Wow. How many sigma bonds carbon has? Very good. 2 sigma bonds. Why? Here, this is a sigma bond. Out of these 3, only 1 is sigma bond. Then how many sigma bonds are there? 2 sigma bonds. Well done. This carbon has 2 sigma bond. Then what is the hybridization of this carbon? sp. One S and one P, right? I ask you to join like this. Okay, join according to the number of orbital involved. Sigma 2 mean answer is sp. They don't have any lone pairs. Then come for nitrogen. What should be the nitrogen's this one? How many sigma bonds are there for nitrogen? Nitrogen also have one sigma bond. How many lone pairs are there for nitrogen? There are only one lone pair. Then one sigma bond, one lone pair. What is the hybridization? sp hybridization. Is it clear, guys? Well done. Right. Okay. Then I will now these three things. I hope you're 100% clear. Then I will do certain questions to do alone. Right. First of all, write these three very beautifully. If you have a writing book or some papers to write, you write in it. The students whoever didn't get the tudes, I will arrange the tudes. Right. Right. Online students, I have uploaded the tude to the chat. You all can download from that. Right. All right. Beautifully complete these things, guys. Right. You people are from the beginning itself, A level. Now, we'll give certain things related to this. You all just try to get these things. Okay. We'll think something like this. C. Then we'll put nitrogen. We'll put chlorine. Okay. Something like this. Okay. Right. This is number 4. Okay. Okay. When there are plus charges and all, you don't consider those things. You just do as it is, right? As the way whatever you're finding, you just do. Okay, you just see the sigma bonds and lone pairs, and you just keep on continuing this. Okay. You don't want to write how many sigma bonds are there, how many lone pairs are there. If you just write the hybridization, that is enough, Puta, right? You just write these things, what is carbon, nitrogen, chlorine, and write the hybridization. You put phosphorus, oxygen, chlorine, and write the hybridization. Right? Here, just write bromine, oxygen, chlorine. Okay. Okay, just do these three things to check your knowledge. How many students didn't get the tunes? Only three, no? Right. Right. Now, I hope Tagal finish. If you're done, you can raise your hand. So draw the figures. Draw the figures and write the answers. Otherwise, when you go home, or there won't be figures. I hope you would have got the answers, right? This I had to put a minus, yeah. I'll put a minus here. That should be minus, yeah. I have missed that minus. Right. Now, okay. What is the carbons? Tattagala will write now. Now, I hope you know these things properly. Tell me how many sigma bonds this carbon has? Carbon has only one sigma bond, right? Carbon has only one sigma bond this side. We'll put what did you write here? What is involved to make the orbital kela? Carbon. What did you write? No. One sigma bond is there. That is okay. In this, one sigma bond is there. And in this one sigma bond mean what did you write for the hybridization of carbon? What is? What is you wrote? You wrote 1s. Right. Good. But it is wrong. What you should write? 4s. No. Tell carbon belong to which period? You know. If you write the periodic table, hydrogen, helium, then lithium, beryllium, boron, carbon. So carbon belong to which period? Carbon belong to second period. Carbon belong to second period. Therefore, which s orbital will involve? Second period's s orbital. Therefore, carbon involved in what orbital? 2. S is the correct answer. It doesn't mean there are 2 s orbitals involved. It means second period's s orbital is involved in 2s. Okay, good. You learned that part. Okay. Now understood how to select the s orbital? Because hydrogen is in the first energy level, that's why it's a 1s orbital. If anything here involved, 2s orbital. Very good. Okay, nitrogen. A nitrogen. You can see around nitrogen, how many sigma bonds are there? 1, 2. 2 sigma bonds. Then what is the hybridization, guys? sp. Well done. There are 2 sigma bonds, sp. Around chlorine. Chlorine, you have 1 sigma bond and 3 lone pairs. 3 pairs lone. Then altogether there are 4 units. Then 4 units now sp3. Okay. If it correct, raise your hand. Well done. So understood, no? Correct. Okay. Phosphorus, oxygen, chlorine. Tell me around phosphorus, how many sigma bonds are there? 4 sigma bonds are there. Right? There are 4 sigma bonds. 1, 2, 3. Out of these 2, only 1 is sigma bond. Then 4 sigma bonds. 4 mean what is that? sp3. Right? Phosphorus is sp3. Everyone clear here? Well done. Then oxygen. How many sigma bonds? 1 sigma bond. How many lone pairs? 3 lone pairs. 1 sigma bond and 3 lone pairs mean altogether how many units? 4 units. Then sp3. Chlorine also 1 sigma bond, 3 lone pairs. I'm sorry. Methana, I can't put. It's wrong. Only it will be like this. Then I'm sorry. There is a mistake. I can't put at 2 electrons there around oxygen. There should be 6. No? All right. Then sp3 name. Then it will be what? Yeah. I did a correction. So according to the correction, you tell the answer. sp3 should change as what? sp2, no? sp2, 1 sigma bond and 2 this one, right? sp2. Okay, good. And this chlorine, 1 sigma bond and 3 lone pairs, then altogether 4 units, sp3. So it's very simple to tell their hybridization. Okay, good. Now the next one, final one. This is a very good one. So you have to tell the bromine's hybridization here. Then tell me how many sigma bonds are there around bromine? 1, 2, 3, 4, 5, 6 sigma bonds. First time you met such an amount of sigma bonds, right? But we did no. 6 sigma bonds mean 1s, 3p, then altogether 4. Then how many d's I should involve for this? I have to involve 2 d's for this. Then only I get altogether 6. 1, 2, 3, 4, 5, 6. Then what is the hybridization of this Br? sp3d2. Who wrote this correctly? sp3d2. Well done. Puta, did you understand hybridization? Are you okay? Right. Next, oxygen. Then how many sigma bonds are there? One sigma bond. How many lone pairs? Two. Then altogether, how many units? 3 units. 3 units mean what should I write? sp2. sp2 is for oxygen. Okay, tell me for chlorine. Chlorine has how many sigma bonds, guys? One sigma bond. And how many lone pairs? 3 lone pairs. Then how many units are there altogether? 4 units. Then what is hybridization? sp3. Well done. Superb. All right. Now, is it 100% clear now hybridization? But hybridization has more meaning than you're writing this sp3d2. Last week, I told that. What is the meaning of hybridization? These orbitals get together to form hybridized orbitals. Okay. So, but although you don't have a big knowledge about hybridization, still you can get full marks in A level. Okay. So, the problem is I can't connect to the screen. If I can connect, it'll be easy for me. Right? Then I can show directly some past paper questions directly on the screen. But if you put a pen drive, I guess you can connect. No? Right, at least I'll try to put a pen drive. All right. Anyhow, after the break, we'll see that. So with this, you can select what is the hybridization of these things, no, guys? Right. So now, we'll go for VS-EPR theory. VS-EPR theory mean VS-EPR theory. Now, this is the theory they are giving to identify the molecular shapes. Okay. What is the meaning of this? Anyone knows this meaning already? Ah, very good. You know, no? Yes, still? Very good. How you know this? Excellent. You have done this then? Then you have done molecular shapes? Right. Okay. So, under VS-EPR theory, actually this means valence shell, V for valence, S for shell, E for electron, P for pair, R for repulsion. Valence shell, okay, electron, pair, repulsion, okay, theory. So, in this theory, they say, they are telling, okay, these sigma bonds and these lone pairs are known as repulsion units. They are known as what units? Repulsion units. They are telling these sigma bonds and the lone pairs are known as repulsion units. What do you mean by repulsion? Repulsion mean they push one another. Okay, they push one another. Electron and electron, they will push. Even electron will push the bonds. Then bonds and bonds also will push. Again, we'll say 2 lone pairs are there. We'll say this is a lone pair. This is another lone pair. Then what they will do, this lone pair will push this lone pair will push this lone pair because both are negatively charged. We'll say this is a lone pair. We'll say this is a bond. Bond mean I'll just put a line. Although in a line, what is here? Inside this line, there is an electron here, there is an electron here. Then what will happen? This lone pair will push the bond will push the lone pair. Then there are also a repulsion. Okay, according to Newton's third law, right? Every action has the same reaction because this will push this. That's why this will push this. So same force they both will have. Okay. So we say this one as lone pair and lone pairs repulsion. Right. This one I say, what is that? Lone pair and bond pair repulsion. Again, this is bonded electrons, this is lone electrons. Third one, between these bonds and bonds, also between the bonds and bonds, there are repulsion. So I call this as bond pair repulsion. Right. Now just imagine, tell me out of these three, 1, 2, 3, which one might be powerful? Which one might be a powerful repulsion? What do you guess? Bond pairs or lone pairs? Who might be very powerful here? Don't check your tutes. Nikang, just try to answer. Bond pairs will be, you are, you know this, so just you are telling. You are guessing. You are guessing. Right. Now lone pair electrons also there. Bond pair electrons also there. Who can push each other? Well, just imagine you're bonded with someone. You and your friend, they're tying together. And two friends are coming, they are free hands. Let's push. Who can push each other very well? The people with free hands or people with the bonded people? Bonded people can push or free hand people can push? Free hand people can push well, no? Therefore, they tell between lone pair and lone pair repulsion is the highest. Okay? This is chemistry, whatever coming through our life. So between when you are free, you can push them more. Then second highest will be whom? Lone pair and the bond pair. Third one will be bond pair and bond pair. Okay, their repulsions are goes in this order. Right? Okay. So take your tute. AK, I have put that. And AK, I have put that part. Check that. Is it there? Then I have put here. Page number. Page number, I guess 4. Page number 4, I have put. Stepler panniga. All right. Okay. Thanks. That. Okay. Oh. Who wants this? Who? Only 2 of you? 3? No? Right. Okay. Now, okay, put a check the page number 4. You can see I have given how these things are there. Okay. Repulsion between two lone pairs of electrons are greater than repulsion between bonding electrons pair and lone pair electrons. And you can put this chart there. So you will understand this one only first, this one second, this one third. Then don't go to by heart this. So when you see this, this is the scenario, you will understand. Right. You can mark those things in page number 5. Page number 5, the 4th. Page 4, I'm sorry. Page 4, you can mark those things. All the things, whatever I'm teaching today, I'm 100% sure you will never forget. Right? When you're going without by hearting the things, this will be in your memory. Right? Right. Okay. Now, Buddha, what are these things? These are all VSC pair units, sigma bonds and the lone pairs. Now, with this, we can build up molecular shapes using this VSCPR theory. Okay. Now, we are going to build up molecular shapes. First of all, I will show you molecular shapes, how these molecular shapes are built up with the sigma bonds. Okay, using these sigma bonds and lone pairs, we build up different shapes. First of all, I'll draw different molecular shapes. I will show you those molecular shapes. Okay, to show these things only, I bought some items. about, okay, atoms. Okay. So using these atoms, we can play, right? What are we going to play? We are going to play cricket, name it. We are going to play atoms, right? We are going to play molecular shapes. So you will understand very well. Okay. Now let's start. Now finally our main purpose is this. Okay. Right. Now guys, now these molecular shapes, I'm going to give different shapes for this. Now just close your papers, everything, and just observe here. Putra, first of all, to make a shape, to give a shape, minimum, there should be 3 atoms. Minimum how many atoms should be there? 3 atoms. If there are anything with 2 atoms, we don't tell a shape for them. For an example, can you tell an example for a molecule which has 2 atoms? Can it? 2 atoms? It should be have only 2 atoms. H2, very good. Hydrogen, H2. You tell another thing. You can tell so many things. Tagala. Process. You tell another thing. HCl, very good. CO, very good. Carbon monoxide. Anything with 2. O2. Right, very good. N2. NO, very good. There are so many things to tell. N2. Okay. Cl2. But CO told already. N also told. It's right. There are so many molecules with 2. F2, very good. NaO, sodium oxide. HF, HCl, HBr, HI, F2, Cl2, Br2, N2, O2, H2, right? You can tell NOCO, right? Likewise, you can tell so many molecules, right? Okay. So those things we don't give a shape. Then minimum I said there should be 3 things. When there are 3 things, guys, the first thing I give, there will be an atom in the central. And if there are only 2 atoms are connected, I tell this shape as, so you can see, okay, you can see this shape. This shape is a straight line. So they told this shape as linear. They gave this shape as linear. So linear mean how many sigma bonds are there, guys? How many sigma bonds are there? 2 sigma bonds. If you see any molecule with 2 sigma bonds, that is a linear. Then if they are having 2 sigma bonds, guys, what is the hybridization of that? So close everything. Close your papers, everything. Don't look at your paper. Just observe here, because I'm going to put everything directly to your head. Right? So just close everything and just free again. Just see this. Sigma 2 mean the hybridization is sp. Everyone understood this shape? Right, great. Second, this first shape. Second shape, Puta, there is a central atom. Around the central atom, I am fixing 3 molecules like this. I'm not giving examples now. If I fix 3 things, this looks like what? Just join and see. It looks like a triangle. They said this is a triangle, but in one plane, right? One plane. Can in one line, in one surface. Okay, that's in one surface. Okay. Then therefore they say this is a triangle, so they gave a name trigonal. Trigonal. If they say triangle ugly, no? Then they will tell chemistry, what is this chemistry? You are doing math scale. Then they said trigonal planar කියලා they said. Trigonal planar. Then how many sigma bonds are here, guys? 3 sigma bonds. Then we say this one, what is hybridization? sp2. These two shapes okay, no? These two molecular shapes okay. Then they will give different molecules and they will ask you to find the shapes. We'll see how to do that later. Now at the moment, we'll see the shapes. Number 2, okay. Number 3. Then number 3 is like this. They connected the first one like this. Okay. Then with 109.5 degrees, they connected another one for this side. They connected another one for this side. Actually, I can't draw this. This is a 3D view, right? They connected one thing like this, another thing like this. But actually, you don't get the idea of how this exists. But I can give you an example. You can think about a tripod. Tripod. How these legs are there. And this one also there. So when you join these guys, you will get a tetrahedron. When you join these things, or when you join these things like this, or you get a tetrahedron here. So we call this shape as what? Tetrahedral. Tetrahedral we call this. Okay, tetrahedral. There are how many sigma bonds in this? 4 sigma bonds. If there are 4 sigma bonds, that shape is tetrahedral. 4 sigma bonds mean what are the involvement? sp3. All right. Still I am talking about this tetrahedral, those shapes only. Right? So far everything okay? Okay. If there are 2 bonds, what is the shape? Linear. 3 means trigonal planar. 4 means tetrahedral. Very good. Number 4. Now you should imagine this, because everything I can't show here. That's why I bought these digiform balls, and I can fix and show it to you. Right? Number 4. Atom is like this. You know trigonal planar, no, Buddha? I said trigonal planar. 1 is here, 1 is here, 1 is here. Now these are trigonal planar. Again, now I am fixing 3 things in a trigonal planar way. Then what I am doing, I am taking this one, rod, something like this. Directly I am putting inside this like this. Then how will it go? This will go directly like this. Then those 3 things will be here like this. No? So this will go inside this. Those two things will be one on this line, one on this line. This thing will be a straight line like this. This will be like a trigonal plane on another, this one. This red color on one plane, this one on another plane. So can you understand that part? Okay. So this shape, what we call, if you draw this in a corner, it will be like this actually. This is the triangle. Then when you join this will be like this. Okay. What we call for this then? This is like this, huh? Like this, like this. This is a triangle, huh? And another one like this, like this. What is this? Trigonal bipyramid කියලා we say this. Yeah, this is a triangular pyramid. There are 2 triangular pyramids, one like this, another one like this. There are 2 triangular pyramids, one on each other. So we call this as what? Trigonal. Still put the trigonal. There are 2 pyramids, no? So trigonal bipyramid කියලා we tell this. Trigonal bipyramid. So how many sigma bonds are here? 5 sigma bonds. Then what is the hybridization? sp3d. 1 d will be added. So far is in. So far no problem. Right. We'll go for. This is the last thing. After that finish. Finish? No, my cert or something else. No, not finish. Main figures are finished. Right? Hurry. Then number 5. Number 5, like this. Everyone okay with this? Okay. Now number 5. This is the central atom. Around this, first of all, I will fix 4 like this. Like a square. All in one plane. Okay. It means if I mark in color, it means they all lies in the same plan, right? So this is one. Even they will ask about the plan also in the exam, whether they lie in the same plan or they lie in different plans. They will ask in the exam like that. There's a properly, when you are learning, learn it properly. And this is a square things. No? Again, just a square. I'm arranging like this on the board. And here was what I'm doing. I'm taking a rod like this and I'm sending inside this. So you can understand how will it stay, right? So if we, how will it be? One will be up, one will be down. So if I draw this, how will it be? It is like a square like this. For this square, what I'm doing, I'm connecting these things. Then what will I get? Here I'm getting octahedral shape. What is this? 8 sides are there. Therefore, we say this one as what shape? Octahedral. Octahedral shape. Then how many sigmas are here? 6 sigmas. This is the maximum number of sigmas can have. Maximum number of sigmas are 6 sigmas. If there are 6 sigmas, guys, we call it as what shape? Octahedral. Then what is this one? sp3d2. Right. So these are known as the basic molecular shapes. Okay, there are how many basic molecular shapes? Only 5. Shall we recall this? Okay, who can remember everything? Who can remember everything? Just you have to remember the shape, that's it. No one can remember. Don't get scared, guys. Come forward. Right? I know you can, but you don't want to show because others will get jealous of you. Right? The other first thing. Then I'll openly all speak. Okay. Sigma 2 mean what is the shape? Okay. Sigma 3, trigonal planar. Sigma 4, tetrahedral. Sigma 5, trigonal bipyramid. Sigma 6, octahedral. That's it. Can you remember the shapes also? How it was? Linear mean like this. Right? Trigonal planar mean this is one thing mean like this. Right? That is trigonal planar. Other one, what is it? Tetrahedral. I don't know how to do it. Right? I can't do that, right? If I do some, I end in some problem, right? Then tetrahedral, how is it? Like it is like tripod, yeah, tripod. This is tetrahedral. This is tripod. Okay. Okay. Right. Then 5 mean, yeah, it is trigonal planar and linear connected together. Trigonal planar, then linear was ending through it. Ethokota you get the trigonal bipyramid. Sigma 6 mean octahedral. Right. Now I'll show these shapes. Okay. After that, what we do, we will start to remove the sigma bonds. When we remove a sigma bond, what will happen? 2 lone pairs will remain there. Again, for an example, we'll say, now this is trigonal planar. Trigonal planar. Now, how many electrons are there? 1, 2 electrons are there. So what I'm going to do here, I'm going to erase this. I'm going to take this off. Then, if I take this off, 2 electrons will be on this. No? Then the shape changes. Then we get another shape on this. Ava will speak. First of all, we'll speak the basic things and go. Okay. Now, again, from sigma 3, carefully observe. I'll explain this one also. I'll show everything here. What was the shape of sigma 3? Come again. Right. This is sigma 3, right? Now, I'm talking what I can get with sigma 3. If I take one by one, what are the shapes will come here, I will show you. Other things are okay, basic things are okay, no, guys? Right, well done. Basic things okay, shall we check again? Sigma 4. It's processing, no? Sigma 4, what? Tetrahedral, very good. Sigma 5. Sigma 5? Trigonal bipyramid. Okay, well done. Sigma 3. Trigonal plan. Okay, well done. Sigma 6. octahedral. Sigma 2, linear. Now you are okay. Right. Now sigma 3, I'll start with sigma 2 because sigma 2, if I remove one thing, we can't get a shape. So we are not going to remove things from sigma 2. So we are going to first remove the things from sigma 3. So sigma 3, I will remove this one. This one, no, this one. I can remove anything, but anyhow, the shape will be same. Now I will speak about the angles also here. Carefully listen. Most of the students, they have a problem, but I will tell some simple methods to do these things very clearly. Okay. The first thing is, guys, this, what is the, around this, what is the degree? 316. Then what is the degree of this? 120. So if it a trigonal plane, the angle between the atoms are 120 degrees. Then linear mean 180 degrees. Well done. Now I'm going to remove this like this. When I remove like this, what will happen? I get this. Then these two places are removed. Then what will happen, Puta? These electrons will push these bonds like this. By electrons repulsion is known. Therefore, they will push these bonds. Remember, I will tell a small technique. Okay, these are tactful things. Okay, everyone won't tell this. What is that? From each electron, they will reduce the angle by 1 degree. From each electron, they will reduce the angle by how many degrees? 1 degree. Again, how many electrons are there? 2 electrons. Then they will reduce the angle by how many degrees? 2 degrees. Then what would be the angle here, guys? 118. Very good. 118. By earlier it was 120. Now they will reduce by 2 degrees. Now 118. Very nice. Right. So we tell, now what is this, Puta? Sigma 2 and lone pair how much? 1. Sigma 2 and lone pair 1 mean, this looks like what? Angular shape. No? Then we can give this one as, the shape is what? Angular. Angular. Nothing we can tell this V shape. Nothing we can tell this bent. Bent kelat we can say. They give 3 names for this. It's like an angle or V shape or bent shape. Anything is correct. Easy, no? Right. So we are not going to by heart this. And from this, we are taking a trigonal planar. When we remove one, then sigma 2 and lone pair 1 mean the shape is angular. Clear? Good. Now we'll go for sigma 4. Can we remove further? Can't. We are not going to remove further. Right. Now, guys, we'll come for sigma 4. What is the sigma 4 shape? You know sigma 4. What is that? Tetrahedral. You know how was it? One is like this, and other 3 things. One is actually here. One is actually here. Other one is here. Other one is here. Right? Okay. These are like a tripod. Between any two, you know what is the degree? Answer is this not going in a this doesn't lie in the same plan. Huh? Different things lies in different plans. This is not a circle, right? Don't think, oh, this is a circle killer. No, it's not a circle. It is not a circle. Remember, each thing has this number. You have to remember 109.5 degrees. How much? 109.5 degrees. So if someone says, so if we write 109, will they put wrong? Then I will say no. If I write 110, will they put wrong? Then I will say no. These are approximate values. Okay. These are approximate values. So then if I put 112, they'll put wrong. I have don't change much. To tuck 1 degree, it's fine. Then this is okay. Now we'll remove one by one. Now I'm going to remove. These all are symmetrical. These all are symmetrical. Even if you keep this in this side also, it will be what? Tetrahedral. If you just rotate for this side and if you keep, that also will be tetrahedral. Because all are identical, symmetrical. Right? But in the picture, it doesn't seem to be like that. But really, it's symmetrical. Then, next one we'll see. If I remove one, I'm going to remove this one. No? I'm going to remove this one. I remove this. Now I removed this. But now This shape is like actually, can you give a name? Looks like what? Looks like a triangle now. Actually, this is like this now. Tripods. Now, this is a tripod. No? If I remove the tripod's top part like this, the balance part will look like what? Like a like a like a pyramid. It will be like a pyramid. Yeah, it will be like just pyramid. We don't put any trigonal. We don't put just it looks like a pyramid. What we say? If there are if there are three sigmas and one lone pair, if there is three sigmas and one lone pair, we give a shape for these guys. What is that? Pyramidal. What is the shape of this? Pyramidal. Right, we give a shape pyramidal. Right. Then if I remove 2, I can remove 2, no? We'll remove 2 now. We'll remove 2 and now this is there. Now this part and this part. Already I removed this. Now I removed this now. Now this looks like what? Now what it has? Now earlier it had 4 sigmas. From that I removed 2 sigmas. Now those 2 sigmas became 2 lone pairs now. Okay. Again, if someone says 2 sigma, 2 lone pair, then what is the shape of this? This also look angular. So this also look angular. Then here also we say same thing. Name is angular. I tell the name as angular. Very easy. Right? Angular or bent. Both are okay. Right. Now let's see the angle. I said this is 109.5. Right? Then this will be how much? Can you tell? 107.5. Very good. By 2 degrees will reduce. No? Then 107.5. Between everything, 107.5. Clear? No? Then what will be this? Approximate value. Another 2 degrees will reduce. Then 105.5. Putha, doesn't it seems to be like you have seen this somewhere? Like water molecule, no? Water molecule shape is only angular shape. That's why in O level you do like this. Water. That's why you do like this. At that time in O level you don't draw with the shapes, but you do like this because it's like this. Okay. Remember, if someone says sigma 2 lone pair 2 means there are 4 units. 4 units mean it should be a tetrahedral. From tetrahedral they have removed 2. When they have removed 2, what they get? Angular. You have to think like that. Then you will never confuse. If someone says sigma 2 and lone pair 1, then you have to say how many repulsion units are there. How many repulsion units are there altogether? 3 units. The 3 mean it's a trigonal planar. From trigonal planar, when they remove 1, then only you get sigma 2 and lone pair 1. Either what is the shape? Angular. Can you all understand what I am telling? Okay. We don't by heart this. Here we are by hearting. Sigma 2, 1. What is that? What is that? Pyramidal. If we try to by heart, right? If we try to by heart like that, remember guys, you can't do chemistry. Okay, chemistry is actually a very beautiful subject. Most of the math students think we have to chemistry is boring because we have to by heart. Actually, no. Chemistry, you have to remember only 40%, 60% logical. It's very nice subject, right? So understand the secret of it. So here are what nice, right? Okay. Now 4 things are okay. Can you remember so far everything we did? Okay. Can remember? No? We'll assume you can remember. Right. Finally, we will have a test on this. Right. Number. Now we did the things for sigma 4. Now let's do for sigma 5. Right. Carefully observe this. Sigma 5. Can you remember the shapes of sigma 5? Can what actually how? A trigonal planar was there. For that trigonal planar, you put something inside. Linear shape. Like this. Now we'll remove one by one. I'll remove this one first. I'm going to remove which one first? This one first. Then I'll get like this now. I'll get like this. Then what is this? Sigma how much? Sigma 4 Lone pair, 1. What it looks like? You would have learned it. Otherwise, you'll never say this name. What it looks like? No, I didn't ask the molecule. Yeah. In day-to-day life, looks like an alien. Mm. Actually, if I turn to this side, you can tell this. I'll turn. I'll turn like this. How is like? What is this? You play, bang? Puta, can you take that water to that one? Can you take the glass for that? Yesterday glass, Taraparas went. Right. Okay, thanks. Puta, you're playing this no? Are with 2 people? Or what is this? Are you play this? What is this? Are you play like this? What is that? See, so up and down. Then, that's only this. It looks like someone telling hi for you, right? Actually, is that seesaw? Okay, we don't by heart this or with the shapes we tell. I think actually this would have given by definitely a boy. By boys only give simple names. Okay, seesaw. You would have seen, this is like a seesaw or is it seesaw? Like Dalton said, when people ask, what is this, how this, what atoms looks like? He saw what ball and he said, it's like golf ball. Some says he saw billiard ball and he's saying billiard ball. But in Sri Lankan government syllabus, they took golf ball. That's why they say golf ball model. Most of the things they took with day-to-day life. How Niels Bohr said, Niels Bohr, Thomson said, for electrons, he thought his wife's pudding. Okay, the pudding made by his wife. When he's eating the pudding, he's like, for him, it's like, but electrons are, those plums are like electrons for him. The scientists are like that. Whenever they see even a food, they will think about things. Hereafter, you also think like that. When you see a garlic, you think about the kidney, right? Hare? Sir, you should improve like that. Okay. Now, garlic is kidney shape, no? Beans also kidney shape. Right? Beans kidney shape, no? Bean seeds. Right? Beans are like snakes, right? The seeds are like kidneys, right? Anyhow, this is so. Then we'll remove 2. Actually, I can't show exactly the thing on this. That's the issue. That if I can show this, it is very nice. But unfortunately, I can't show it. The thing is, here, what is the degree here? This is 120. No? Between these things, 120. Between this side, it is from here to here. This blue color line, 180. Blue is 180. So it is actually like this. Then this 180 line is exactly as it is. 180 is as it is. Then what will happen? If I remove this, this will reduce this one. Then between this, how many degrees? 118 degrees. Can you understand? Easy ways to get these things. Okay. Right. So this is so. Fine. We'll remove 2, but actually, if I remove 2, I can't show actually on this. Okay. If I remove 1 from this, if I remove 1 from this, how will it look like? Again, one more. I'm going to remove 1 more. Again, if I remove 1 more, this becomes sigma how much? Sigma will be 3. No? 1 lone pair will increase, right? Again. Then actually, if I remove another thing, actually, I can't see in this, but it will look like this. I'll remove 1 from this, right? If I remove 1 from this, it will look like actually, Buddha, like this. It will look like this actually. Like, but I can show this here exactly. So I have removed 2 pairs like this. Okay, now this is trigonal plan. The trigonal plan. I have removed these 2. Then this and this will form a shape. This looks like what? This looks like an English letter. No? What is that letter? T. These are given by males. T shape. Okay, it looks like T. So okay, what is this? This is T shape. They gave the name. Okay, they gave T shape. So sigma 3, lone pair 2. Okay. So these things also not. Again, these are derivatives of sigma 5. From sigma 5, you can build up these things. We never by heart. Sigma 4 and lone pair 1 means C. So sigma 3 and lone pair 2 mean T. We never by heart. Right? Again, from 5, when you remove 1, you get a C. So from the C, so if you remove, you get a T. Okay. Right. That part also okay. Then finally, we have to remove only one more thing. Then the entire molecular shapes are done and dusted. Right? So let's see. Sigma 6. Sigma 6, how is the shape? If you have an imaginary power, you can imagine 3D. Okay. But nowadays, students' imaginary power has gone. I don't know why it has gone. It's very less. Nowadays, students can't imagine much. Because you all don't listen for grandmother's stories. Nowadays, most of the children, they hate to read. Who love to read here? Seriously. Am I wrong? You love to read? Siravada? Very nice. You love to read or you love to watch movies? Read more than watching movies. So when you're reading, those scenarios will come to your head. And then your imagination power is good. Then you can do maths and science well. You people, you love to watch videos than reading. Then your imaginary power is less. Why? You can imagine while reading. Because the people who can imagine, or when they are reading, they will go into the book. They won't feel any other thing. They are living with that story. What's going to happen next? What's next? Okay, that thrill, the people, only the readers know that. What we call for the reading people? Nerd not nerd. Bookworms Bookworms, yeah, bookworms mean always there with the books. Right. Tell me a word for that. There is a good word. I can't remember exactly. Right. Good. I'm very happy to see such kids in this generation. Right? You all love to read? Okay, good. Now sigma 6. What is the shape of sigma 6? Sigma 6 can, this is what? Between this actual 90 degrees. This is like, what is this? These are 90 degrees. These are placed on 90 degrees. And this one placed directly into this. It is between this line and this line. There is 180. This red line and this red line, 180. These black lines, 90. Can understand that? Good. Now we'll remove one by one. Then when we remove one by one, guys, it'll be like this. Right? We'll remove one by one. First of all, we'll remove this one. I'll remove. Okay, I'll remove this one. Then I'll get. Then tell me what I'll get. Sigma how much? 5. Lone pair 1. Still, these also having the same 6 repulsion units. Repulsion units are same. That's according to VSEPR theory. We are checking how many repulsion units. So these all become to one category. This also having 6 repulsion units. This also having 6 repulsion units. But 6 repulsion units, 5 sigma, 1 lone pair. 1 is lone pair. Then if I remove this will be empty here, right? This is like this. This is like this. This is like this. This is like this. And this is like this. Okay. Then what is this? How I can draw this? What comes to your head? This is like what? Can you see this is like a triangle pyramid? Square pyramid. This is like what pyramidal? This is also like a pyramid, but what pyramid? Square pyramidal. Earlier also we got some pyramidal shape, no? Which pyramidal? When we remove something, we got a pyramidal. Can you remember a tetrahedral? When we remove one, we got a pyramidal. That one we say just pyramidal. Here we say what pyramidal? Square pyramidal. Right? Then what we say for this? This one is what, Puta? Square pyramidal. Okay. Square pyramidal. So, then what are we going to do? We are going to remove one more. If I remove one more, sigma will be how much, guys? 4. Lone pair will be 2. So next one, I'm going to remove this one. I'll remove this one, right? I'll remove this. So when I remove that, I'm going to remove that like this. Okay, already this is removed. Now what I'm going to do? I'm going to remove this. When I remove this, what will happen? Now I'm going to remove this. I'll remove this, right? Removed. Then what will happen? What is the shape now? Now these are like only a square is there. There what we call which one? Earlier we said for triangle we said trigonal plan කියලා. We said trigonal plan. But this one square, so we say square what plan කියලා we say this. This square plan. Very simple, very nice. With this all the shapes coming to an end. Then so aren't we going to remove these things? No, මෙච්චරයි. We are not going to remove further. So did we by heart anything? No, but you might have chutta forgetfulness. But anyhow, you understood everything, how to get these things. You understood without by hearting we can get this. I'm happy about that. Right. Now, guys, what shall we do? We'll see these shapes. We'll give examples for this. But before the examples, we'll see this, actually how these things are there. Right? Okay. Now, what I want to do, I just get these bows. And I want a small support from your side. What I want is pen. If you can give me 6 pens, then I can show everything to you. What I want is just 6 pens. Okay, because we are going to do things with these balls. Okay. So you know the owners of the pens, right? Whose pen? All yours. Yes. Now, what I want to do is, I want 6 pens. Okay, 6 pens are here. Then, first thing, we'll see the linear shape, right? We'll see the linear shape. So I will remove these things. Huh? Okay. Then this is the big one, right? Everyone can see, right? The big one, right? Then take this. Okay. Then we'll put it like this. Okay, now I'm going to fix the molecules. Right. Right. Then if I fix one side here, if I fix the other side here, what is this? What is this? Linear shape, right? So this is the linear one. Again, everyone can see, right? So this is the linear. The same thing. Now I'm going to make a trigonal planar for this. Right? I'm going to make a trigonal planar while keeping the linear this side. Right? I'll make the trigonal planar. Right? Like this. Right. Right. Can you see properly? If you want, you can come here. You can stand and come here. Lazy people, right? Anyhow, so I'll remove these two. Right. What is this then? Now this is only trigonal plane. You want to see this? No need. Can see from there. Right. This is only trigonal plane, so you can see 120 degrees in this. Right. Then when I fix 4, but before fixing 4, I'll come for the 5. 4 I will show later. 5 I will show you now. This is 5. This is 5. If I fix like this is how much? 5 sigma bonds are there. 1, 2, 3, 4, 5. Right? Okay. Now in trigonal plane, these 5 things also there. If I fix 5, what is the shape? Trigonal. What is the shape of the? If I fix 5 things, what is that name? Trigonal bipyramid. Right? This is the triangle. Can you see these 3 lines in one plane? This one goes straight. Right? You can see. Right? Okay. Right? Everyone clear? Ne? Right. So you get a good idea on this. Right. Then this is what? Trigonal bipyramid. Okay? It's like this. This is 5 trigonal bipyramid. Now I'll make this as a trigonal plane. Now this is trigonal plane. Now in this trigonal plane, now what I'm going to do? I'm going to remove 1. If I remove 1, what is the shape? Linear. I'm sorry, linear. Angular. What is this shape? Angular. Now this is angular. That's why we say when I remove 1, this becomes angular. Now here are 2 lone pairs you should imagine. Right. Again. Right. Now what is this? Trigonal plane again. Right. Now what I do? I come for trigonal bipyramid. This is 120, between these two 180. Now what I will do? First I will remove 1 from this, right? I should remove 1 from this, no? From trigonal bipyramid, I should remove 1, right? When I remove 1, what is the shape here? This is seesaw. What is this? Seesaw. So if I keep it on the table, you can say how we are doing seesaw. This is seesaw. Like seesaw, no? Can you put the camera for this? Or you can remove that and you can put a show. Or other camera, you can remove it. Yeah, you can take it up. Yes. Put a show, you can see here. You can see there. They can see or not. This is only what? Seesaw. Or you can see it's nicely going. Can see, no? Right. It's like seesaw beautifully. It is there. So that's why you say seesaw. Nicely seesaw is there. That's why. Right? Okay. Thanks. Right. Now that part also fine. Seesaw also okay. Right? Okay. Well done. Now seesaw okay. So if I remove 1, I got seesaw. Now if I remove 1, I got seesaw. If I remove 2, I said I can show in other thing. Now I can show in this. If I remove 2, what is this shape? T shape. That's why we got the T here. Okay. That's why you can remove and see one by one. Okay. It's like a human also. Right. It's like, what is the shape? T shape. Okay. Now these things are again. Right. Can we remove one more? We are not removing one more. Right. We can remove one more. I'm sorry. But then I can remove one more. I can remove this. Right. And I didn't tell here. Right. Put that here, T shape. In this, I can remove one more. Again, I can remove this. If I remove that, here becomes sigma 2. Lone pair how much? 3. Then what is that shape? That is linear again. But how that will be linear? One is like this, one is like this. Here 2 and here 1 we have removed. Okay. So I am going to remove that one here. Now what is this? Linear. Okay. Then in 5, when we come to 5 bonds, once 5 sigma bonds, we remove 3 things. We remove 3 things and we get the shapes like this. So what is this? This is linear. So with this, 5 things are done. Okay. Now we have to go for Now I didn't show you what? I didn't show 4 bonds and 6 bonds. Okay. Now 4 bonds and 6 bonds, I have to do it. I have to put holes in different places now. Okay. First of all, I'll show you the tripod. Right? How the tripod is there? One is here. From this 109 degrees, can more than 120. More than 120, like here. More than 120, less than 120. Something like this. I will have this. Okay. Then I will have this one. Okay, I will have this. Okay. Then this is between these two 109 degrees. Okay. If I take from this side, between this and this also there should be 109 degrees. Between this and this also there should be 109 degrees. So I have to mark somewhere like this. Okay. Right. Mark like this also, I should get this. And the other one, these two things are there. Here also there should be 109 degrees. All right. Now see this. Now, this is only what? What is this shape? Pyramidal. Even if you take for any direction, it should be a pyramidal. Right? Anyhow, this should be, what is this shape? Pyramidal. Pyramidal. What is this shape? Tetrahedral. This is tetrahedral. From tetrahedral, if I remove one, and it will be what? Pyramidal. Tetrahedral will become pyramidal after removing one. This is a tetrahedral. This is pyramidal. Right? That part is okay. Right. And if I remove one more, this become angular. Right? Angular bend shape. Okay, or V shape. Those things are clear. So these things are okay. Online students also can understand. Right. Then we have to go for now only six sigma bonds. How can I go for 6 sigma bonds? It is between these two, this having 90 degrees. Between this and this also, it should have 90 degrees. Okay. These are connected with 90 degrees. Huh? Okay, anyhow, this is one thing. This one. These things are looks lollipops, no? This is one. And I'll take one here. One. Another one here. Right. So this is, first of all, this is the first part. First of all, we have to make a square thing like this. First, we have to make a square like this. First, we have to make a square. After that, I have to put a linear part for this side. Right. If I put the linear part, it will be like this. This one. This one second. Okay. This one second. Again. This one thing, this other thing. Now can we, what is this? This is only octahedral. This is only octahedral. Okay, again one is in linear, other one as a what? Square. Right? This is only octahedral. Then Puta, I said no, I will remove one kila. If I remove one from this, what is this? Square pyramidal. You can see, no? This is square pyramidal. And if I remove the second one, it becomes square planar. Square planar, I mean all 4 things in what line? One line, one plan, right? So only this much. Only these molecular shapes are there. So can you remember all the molecular shapes? Right? Okay. If you want, you can try and see. I will send this. Right? You can try different shapes and see. Right? Right. You want to try and see? Right. Try and see in the interval, right? I'll give you a small break and then you come and try and see. You don't make the different right. Anyhow, it was making, we don't have a use. If you want, you can take home and you can try different shapes, right? You can make robots. Then finally, our purpose is this. So I hope which one you understood. When I explained the board itself, you understood everything. Or when I explained from this, you understood even further. Like even further, you understood everything, no? Right? That's nice. Right. Now, can you build up this complete note alone without looking at the board? Sigma 1, sigma, first sigma 3, sorry, first sigma 2, sigma 3, sigma 4, sigma 5, sigma 6. Then after that, from there, you have to go branches. From sigma 3, you have to go sigma 2 lone pair 1. From sigma 4, you have to go sigma 3 lone pair 1, sigma 2 lone pair 2. From sigma 4, you have to go sigma 3 lone pair 1, sigma 2 lone pair 2. Then sigma 5, no, don't think it's difficult, it's easy. Sigma 5 we gotta come. Then from sigma 5, sigma 4 lone pair 1, sigma 3 lone pair 2, sigma 2 lone pair 3. Then sigma 6 comes. Sigma 6 means sigma 5 lone pair 1, sigma 5 lone pair 2. Just try this. Again, I'll give some time. I'll show everything. Just try these things. You just, now I showed, first I drew on the board. I showed you different things. With this, you try to build up. You try to build up this. If you are scared, you try to build up in a rough note. You can take a rough page and you can build up if you're scared. If not, you can write within a writing book itself, or you can just take a rough paper and you can first build up these things alone. You do whatever you want. First, but try. Don't give up. It is easy. Don't, please don't check with your neighbor. Try to do alone. It was, we'll see one by one again. Because when you are leaving today, you should know these shapes without by hearting these things. Right. We'll start. So you want your pens, right? Ah. Okay, now let's see. Now check from the beginning. You all see these shapes. I started from here. If it is correct, correct code. If these things are correct, you can be happy. Okay, because normally students put a big effort to remember these things, right? So now, in the first instance, if you can do, really, it's worth it, right? All these shapes are given in the tute. You check, all these shapes are given. Okay, page number. Wait. All these things are given here. Okay. Right. Page number 4 and 5. You can see 4 and 5. Again. Right. Okay. Now, we'll go for certain examples on this. We'll go for the other ones. Agali, you just correct these things. I hope all these things are already written. Just you have to double check what you have done is correct. Yeah, but more than that, this pattern, you will understand. Okay, all these are 3 repulsion units. Check this is correct. If it's correct, you can be happy. Done. Right. Then next, these 3 units. Then next one. This one. These are all are 4 repulsion units. All 4 sigma, 3 sigma, 1 lone pair, 2 sigma, 2 lone pair. Right. And the next one. Right. And the next one. This is number 8. This is number 8. Everything came from this. Again, normally in the sigma 5, only in sigma 5, we remove three things. Every other thing, we remove only maximum 2. When the sigma 4 also, we remove 2. Sigma 3, we removed 1. Sigma 4, remove it 2. Sigma 5, we removed 3. Sigma 6, we removed 2. Okay. Then, okay. Actually, they won't ask this alone. They will ask this with Lewis structure, right? With the Lewis structure only, they will ask the shape of these things, right? They will go from basic to advanced. Right. The final one. This. These all came from octahedral. From octahedral, you got square pyramidal, you got square plan. Okay. So you said you had a confusion in this? Yeah. You said you didn't understand much, Kiel. Right. Okay. Then this part is okay. Right. Now let's see a few examples and we'll decide their shapes. We'll decide their shapes. All right. Now, all right. Now they will ask you to deduce shapes using VSCPR theory. Right. They will ask you to deduce shapes. First of all, I will take beryllium chloride. Beryllium chloride. So if you want to draw beryllium chloride, Puta, you will draw like this. You will draw like this. BeCl2. Beryllium is there. 2 chlorine is here. It means you should know to draw Lewis structures. Lewis structures, but everything we completed. Right? The students, if you have a problem or no problem, right? Or we can do. Then this is chlorine. Right? Okay. Now this is only BeCl2. Now, if you want to see a molecular shape, you have to see the central atom. Around the central atom, when you are deducing the shape, Puta, there are certain steps to write to deduce the shape. What is the first step to write? The first step to write is, guys, you have to write first thing VSEPR, okay, units. Unit scale you should write. How many VSEPR units are there? Around the central atom. Central atom is beryllium. Around the central atom, how many VSEPR units are there? Who are the VSEPR units? Sigma bonds and lone pairs. Those are VSEPR units. Then you write how many VSEPR units are there. Answer is 2. Next one you write lone pairs. How many lone pairs are there, guys? Answer is 0. No, lone pairs around the central atom. We are talking only about the central atom. We are talking only about the central atom, who is in the middle. We are talking only about the central atom. Lone pairs are 0. Then you can put another thing like this, sigma bond scale up, you can write. Sigma bonds. How many sigma bonds are there? 2. Then I can write, finally, the shape, shape. There are 2 things, Buddha, right? One is there, careful listen. One is there, electron pair geometry. There is a thing called electron pair geometry. Then electron pair geometry means we tell the electron pair geometry using the VSEPR units. Okay, if there are 2 VSEPR units mean, it means 2 VSEPR units mean, what is the shape? Linear shape. 2 VSEPR unit mean there are 2 sigma bonds mean. At the beginning I gave basic 5 shapes. No? When 2 sigma, when 3 sigma, when 4 sigma, 5 sigma, 6 sigma, I give 5 basic shapes. No? You have to put only those basic shapes for electron pair geometry. There are 2 VSEPR units mean, what is the shape? Answer will be linear. Third one, I have to write molecular shape. Final one, molecular shape. Molecular shape is what? What is the molecular shape? Molecular shape also what is here? Linear. Because only 2 sigma bonds are there. Okay, remember this electron pair geometry, no need to write when they ask to deduce the shape. Here I just gave this one to you. It means you should know what is electron pair geometry. Is it clear? But you should write when they ask you to, when they ask you in exam, deduce the shape KL, they will give deduce the shape. Deduce the shape. of the molecule. They will give like this. Right? This is the shape of the molecule. So when they give like this, you should know. Okay, you have to do like this. Okay, this is beryllium chloride. I'll give one more. We'll think again in that one, this unit not needed. This step not needed. But other steps you should write like this. Okay, good. Now next part. We'll give something like this. I'll give you, this is, we'll think this one. XE, this XE. XE mean, have you seen XE? XE means xenon. XE, and I'll put XCF4. This is the shape. Then if you draw the Lewis structure, you get two electrons like this. I guess you now itself you can identify what is the shape of this scale. You can tell, no? You know the shape, no? What is the shape? Just tell. Square planar. Very good. Excellent. Superb. Everyone can say, no, this is square planar. Okay. But when you're writing this, at once, if you write square planar, you won't get full marks. The first thing, what should I write? I have to write these things like this. Okay. But I have an opportunity like this. Right. But if you also can do that, you can do that. Okay. That's an advantage of this. Right. So therefore, you can use short terms. For other things, you can use to short terms. VS CPR units, you can use the full term. Other thing, LP, sigma, KL, you can use short terms. And I said, no, this is not a necessary step, but I will write this here to understand this. Huh? But when they ask in exam, no need to write this step. VS CPR units, how much? Come on, answer. Tell, answer. VS CPR units? What's the answer? 6, right? 1, 2, 3, 4, 5, 6. Pair is, one pair is 1 unit. Then VS CPR unit 6. So I can write 6 here. Very good. Lone pairs, you can see 2. Sigma bonds, 4. Electron pair geometry decided by what? VSEPR units. How many VSEPR units? 6. What is the shape for 6 sigma bonds? Octahedral. Very good. So what is then electron pair geometry? Octahedral. Very good. What is the molecular shape? Square planar. So understood, these things are easy, Kiela. Easy, no? Nice. Okay. We'll go for one more thing. Okay. Actually, they will ask you to draw this. You have to draw this and you have to get this. So you should know Lewis structures. We have completed Lewis structures part. I think I'm not going to show how to draw Lewis structures now. I'll draw the Lewis structure and I will ask you, right? Right. Now they are giving like this. Shall I give a difficult one or same easy ones? You'll have still easy ones. A difficult one. Easy one. Difficult. Everyone loves difficult, no? Everyone loves difficult. Okay, we'll give like this then. Okay. Now I'm not drawing according to the molecular shape. Huh? Okay. Right. Now they will ask, what is the shape of the second carbon and what is the molecular shape of the third carbon? You just think if you can think and answer. What is the molecular shape of the second carbon? What is the molecular shape of the third carbon? Right. You just think and answer. Don't tell. Who are done? Done. Still processing. What is the molecular shape around the second carbon? What is the molecular shape around the third carbon? Online students, you can put the answers in the chat box. Right. Okay. Got? Right. Okay. Tell me what is the second one? Linear. Well done. Third one? Tetrahedral. Excellent. Can you tell what is the second one hybridization? Second carbon's hybridization? sp. Very good. Third carbon's hybridization? sp3. Well done. Why here? How to check that? If I want to check the second carbon shape, okay, I have to write these things. This full set I should write. Okay. Again, in the exam, I have to write this full set. Right. I have to write all these things. Right. This for carbon 2. Okay. This for carbon 2. And same thing, I can take one more thing. This for carbon 3. Okay. This for carbon 2, this for carbon 3. Now, this for carbon 2, we say C2 kila. This for carbon 2. Okay. Then carbon 2 mean I can write VSCPR units around this. How many VSCPR units around this? You can see there is a triple bond. Then this is one is sigma bond, this one is sigma bond. This sigma bonds are 2. Lone pairs 0. Sigma bonds 2. Electron pair geometry linear. Molecular shape linear. Sometimes electron pair geometry and molecular shape both are same. Then third one, carbon 3. For carbon 3, if I use this, tell me the VSCPR units around this carbon. 1, 2, 3, 4 sigma bonds. Then VSCPR units 4. Lone pairs? No lone pairs 0. Sigma bonds 4. Electron pair geometry? Yes, very good. It is tetrahedral. What is the molecular shape? Molecular shape is, yes, square plan. Square plan. So molecular shape is square plan. Sorry. See. කවුද මං what this square plan? Who told square plan? What is the molecular shape? That also tetrahedral. This carbon, does it has what, lone pairs? No, no. So molecular shape also what? Same. According to sigma bond and lone pairs only we decide the thing. No? Then that also what? Tetrahedral. I have switched off my brain. Okay. I trusted 100%. Suddenly, right. Okay. Then everything fine. So they can ask things like this as well. Okay, then directly we'll go for some questions, and then now you know how to see the hybridization also. You know how to see the molecular shapes also. So you know how to deduce these things, no? Right? Then write these examples. First of all, you'll write these examples in your writing book. Okay. You can write the heading, deduce the shape of the molecules. Right? Under that, beautifully put this. You can use short words for this. First, in the first one, you write the full thing. Second things, you can use short words. Short words mean you can just put V, for lone pairs put L, put for sigma. Then electron pair geometry mean you put G. Molecular shape you put S. You just put VL sigma GS. You just write these things. Only for the first one, you write the full things. Other things, you can't copy paste. No? So you can just use one word and you can do those things. Beautiful, do this. Right. This is okay. Then let's go. Let's try take the past paper questions. I'll put the past paper questions, but thing is, you should know to go Lewis structures for this, right? Lewis structures, I gave an easy way how to draw Lewis structures, right? If you don't know anything, I can help you. Taggal, I can tell few things for the students. Okay, if you don't know the things, I can help you with these questions, right? Shall I erase this? Shall I take it away? Taggal, right, taggal, right. Okay. Raise your hand if you are not expert in Lewis structures. If you are not expert, not expert, right? Not expert. Okay, right. Okay. I'll tell an easy way. Taggal, I'll recall how to do Lewis structures and I'll go to these questions, right? I'll give you two examples how to do Lewis structures. I'll give two examples and we'll go for that. Right. Lewis structures are actually very easy, guys. We can right. Alright. Now Lewis structures are very easy. We can do like this. Okay. Okay. First of all, take the periodic table. You all got the periodic table with you. Take the periodic table. Yeah, if you have the periodic table, it will be easy for you. Period table is not in this. There is a period table in that, no? There is a period table. There is a period table. Only one period table there. You have your period table? So can you give one period table for that? Can you share? Who's going to give? You're going to give? So you have periodic table? You got that period table. Fine. Okay. Okay, use that periodic table. Okay. Okay, now see this. This is the way to draw Lewis structures. For an example, any molecule you can draw Lewis structure quickly. Any molecule you can draw Lewis structure quickly. You can draw the Lewis structure. For an example, I will classify this under two categories. Two categories mean, first one is for period 2. Period 2 elements. If you get period 2 as the central atom. Central atom is the period 2 element mean you can follow this method. Okay. If the central atom is period 3 or above, that mean you can use the other methods. Right. If the central atom is period 2 Puta, right, you can do like this. Okay, you can do like this. You can count the number of bonds and you can do. For an example, I will just explain for CO2. I'll explain for CO2. I'll explain for another thing. I'll explain for something like NO3 minus. Okay, I'll explain for this. How to draw NO3 minus. Then first of all, you have to see, okay, if you write like this, second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay. Then their group number will be 1, 2, 3, 4, 5, 6, 7. This is their group number. Okay. Their valency number I can write. Their valency number, Vn mean valency number. I can write like this. 1, 2, 3, 4, 3, 2, 1 kilo I can write. That part you know already. Then Buddha, for NO3 minus, if I want to draw this, what I have to do? I have to see all the molecules. Nitrogen means one nitrogen is there. What is nitrogen's valency? Tell me. 3. Then put 3 here. How many oxygens are here? 3 oxygens are here. What is the valency of 1 oxygen? 2. Then 3 oxygens valency altogether? 6. 3 into 2, 6. Then put 6 here. There is a charge also no here. What is this charge? Minus 1 charge. Then put minus here. Okay, minus 1. Then put the charge here, minus 1. Like this you write. Then 3 and 6 how much? 9. 9 minus 1? 8. Then there are 8 things. 8 will come here. Then with this you can take number of bonds. Number of bonds mean whatever the number comes here, divide by 2. When you divide this by 2, you get 4 bonds. You get. Again, in this molecule, there are only 4 bonds here. Then first of all, you draw a structure for this. Structure means however nitrogen should connected to 3 oxygen. No, however nitrogen should get connected to 3 oxygen, that is must. Then what is the second thing you have to do? How many bonds we found? There should be 4 bonds. Then I can put 1 bond. Then I can put only 1 more bond for this. Then I'll put 1 more bond. Okay. 1 more bond. And I can put like this. So if I put 1 more bond like this, then I have to put the charges. First, I have to put the bonds. Second, I have to correct the charges. How to correct the charges? It means you see it with the valency number. What is the oxygen's valency number? 2. Oxygen's valency number is how much? 2. How many bonds they have? 2. So their charge is 0. See nitrogen. What is the nitrogen's valency number? Speak Putha. Nitrogen valency number? 3. But nitrogen have made how many bonds? 1, 2, 3, 4 bonds. When nitrogen have made 4 bonds, mean it has made 1 extra than that. Then 1 extra is nitrogen become plus. Nitrogen valency is 3. It has made 4 bonds. Then it get plus charge. Because it has made 1 extra than their valency. What is the normal oxygen's valency? 2. But oxygen has made only? Oxygen's valency is 2. Then oxygen has made only 1 bond. What does it mean? It means it has made 1 less than their valency number. It means what is the charge? Minus. This also become minus. Can you understand how to put the charges here? So this is the way how you put charge. So when we are doing lots of questions, Taggal, you will get this. To do some questions from the past papers, that's why Taggal, I'm doing a recap. But can you understand? So this is the world's most easiest method. Okay, you can't bring a more easier method than this. If you bring, I agree, that is the easiest method, right? But I don't think you can bring. Yeah, bring. Okay, this is okay for anything in second period, right? Whatever difficult structure you can draw from this within seconds, right? Then after that, now check and see whether the thing is correct. This plus and minus become 0 and only 1 minus charge remains. Then in NO3 minus 100% okay, right? Then this is the structure for NO3 minus, that's it. Then after that, you have to put the electrons, no? Surrounding electrons. Then finally, fill the surrounding electrons. Third step, finally, is fill the surrounding electrons. How to fill the surrounding electrons? Surrounding electrons are equal to their group number. Surrounding electrons are equal to what? Group number. Okay. Then oxygen, what is the group number? 6. Then oxygen should have 6 electrons. Then oxygen has given how many electrons? 1, 2 have gone for bonding. First and second has gone for bonding. Then another 4 electrons I should draw on oxygen. Nitrogen should have how many electrons? 5 electrons. Then 1, 2, 3, 4. The fifth electron, what has happened? Why I have put plus charge? Then plus charge mean, what does it mean? 1 electron has gone. The meaning of plus is 1 electron has gone. So if 1 electron has gone, there should be 5 electrons, but it should now it's there how many electrons? Now there are only 4 electrons. Why 1 has gone? What do you mean by minus charge? Minus mean they have taken an electron. And normally oxygen should have 6 electrons. Because there is a minus on it, it means there should be how many electrons now? 7 electrons. 7 electrons mean. Now this is 1. This is 1. Now I should draw another 6 around this. Now this is 1. I should draw another 6 around this. So very easy. Very simple. This is the way how to draw for this. Third period things, how to draw, I will just give an idea. Right? If it is third period or above than that, but you have, for an example, I'll draw POCl3. POCl3. Then remember, out of these things, who should be the central atom, guys? Central atom should be the least electronegative element. The central atom should be the least electronegative element. When you take phosphorus, oxygen, and chlorine, the least electronegative element is phosphorus. That you can see from the periodic table. Periodic table, they haven't given the electronegativity. But you know, who are the top people with electronegativity? Can you remember? I told a story, right? Phone. I told a story in single. Phone. Kalot. Brought. Okay. Ice cream denava. Sister. Right? Okay. So this is the electronegativity order. Okay. Phone, chlorine, bromine, iodine. Sulfur, after that only, everyone will come. Okay. This is electronegativity order. Any doubt, Puta? You can ask. Sorry? Yeah, fluorine only having highest. Ionization, electronegativity. Yeah. What, Puta? Yeah, that's I have given the order. Fluorine highest, second oxygen, third nitrogen, fourth only chlorine. Fifth bromine, sixth iodine, seventh sulfur. This is the order. You don't know this. This is the order, right? Fluorine is the highest electronegative element on the earth. No one can exceed fluorine. Highest electronegative element is fluorine. Fluorine's electronegativity value is 4.0. Oxygen is 3.0. Nitrogen is 2.5. Right? The values are like this. No need to remember the value, but this is the electronegativity order. After sulfur only, everyone will come. After this only, other people will come. Normally from left to right, electronegativity, what will happen? Increase or decrease? Left to right, electronegativity will, when you're going from left to right, period, electronegativity will increase. When you are coming from top to bottom, electronegativity will decrease. Top to bottom, electronegativity will decrease. Left to right, electronegativity will increase. In these things, definitely you should know. All right? Okay. And this way, electronegativity increasing. Okay. This way, uh, electronegativity increasing. This way electronegativity decreasing. Right. This way also electronegativity will decrease. This way electronegativity will increase. Okay. Sorry. This way electronegativity will increase. This way electronegativity will reduce. Okay. This way also electronegativity will what happen? This way electronegativity will increase or decrease? It will increase or decrease? Decrease. This way? This way increase. This way decrease. This way increase. Right. Now these things are okay. Now don't much bother about electronegativity. Now our problem is not electronegativity. Now our problem is what? Answering molecular shapes, right? So you ask certain things, that's why I answered this. Anyhow, now, okay. Now, why I told about electronegativity to select the central atom? Why I told about electronegativity to select the central atom, right? Oxygen and chlorine from those lists, no? Those are highest. Phosphorus is lowest. So phosphorus I can draw like this. Then I said, remember for these people, we don't count number of bonds. Third period people, what we do is, we write the central atom. It's very easy. Huh? We write the central atom like this, phosphorus. And we connect the other people with him. Okay, this is a very important thing. We connect the other people with phosphorus, okay, with equivalent to their valency number. For an example, what is the valency of oxygen? Oxygen valency is 2. No? Then I will connect the oxygen for phosphorus with 2, this one. Then chlorine, what is the valency of chlorine? Chlorine is below this one, however, below fluorine or chlorine. Then chlorine's valency also 1. Then chlorine also get connected to this with 1. Then how many chlorines will get connected? 3 chlorines will get connected. Okay. Remember, the central atoms, maximum bonds, maximum number of bonds, that is equal to their what? Maximum number of bonds they can make is equal to their what? Group number. That is equal to their group number. Because phosphorus belongs to 15th group or the 5th group, right? Phosphorus is below nitrogen. Phosphorus is here. So phosphorus group number is 5. Therefore, the maximum number of bonds phosphorus can make is 5. Here phosphorus have made 5 bonds. Then phosphorus is not following the octet rule, right? It is octet rule mean what? There are only 8 electrons around the atom. So phosphorus is not following that. So very simple. Got the point? Okay. This way. That's why phosphorus we draw like this. After that, you can put the other things easily. You can put the other extra electrons around chlorine. Chlorine has 7, oxygen has 6. So this is the most easiest way. Other than that, you can't tell easiest way. Yes, brother? Any doubts? Right. That's why I drew XeF4. Can you remember? Or XeF4, if I put XeOF3 XeOF3 if I put, xenon is a noble gas. No? Xenon belongs to the 8th group. No? Then what is the maximum number of bonds I can make with xenon? Up to 8 bonds I can make. Right? I can make up to 8 bonds. Then xenon, what will happen? If there is only one oxygen, what will happen? That oxygen will come and connect to xenon with double bond. Fluorine, there are 3 fluorines. 3 fluorines will connect like this. Then around xenon, there should be 8 electrons. Now 1, 2, 3, 4, 5. Okay. We'll think XeO2F2 will put. XeO2F2, I'm sorry. So if there is another oxygen, I can connect that with how many electrons? How many I can connect? Another 2. Like this I can connect. Then now how many are there? 1, 2, 3, 4, 5, 6 are there. Then there are 2 extra electrons. No? Then there will be 2 electrons on xenon. Can you see this? Again, around xenon, how many electrons are there? 8 electrons, no guys. Then here 1, 2, 3, 4, 5, 6. Then 2 more electrons on xenon. Then this is the xenon's Lewis structure. Only this much. Around fluorine, there are 7. Right? So directly you can draw this. Again, you just have to connect them with their valency number. Easily you can connect it. Okay, just imagine you want to draw SO4 2 minus. What is the shape of the xenon? Tug a little. Who can tell the shape of the xenon? So then altogether, how many units are there? VACPR units? 1, 2, 3, 4, 5. From 5, they have removed 1. What is the shape? From 5, they have removed 1. What is the shape? Very good, very good. Who said that? Excellent. But for Tuggle, it should Tuggle work out. 5. 5 mean what? Trigonal bipyramid. From trigonal bipyramid, they removed 1. Then what I got? See, got the point? It'll take some time to process, but you will be familiar to this. Can you all understand, guys? Is it okay? Right, well done. Then the next part. Next part is XaO to F2 is okay. Sometimes they will give SO4 2 minus. When they ask SO4 2 minus, these are very easy. But remember, SO4 2 minus means sulfur is in the middle. Sulfur is in the middle. There are 2 minus. No? 2 minus mean whatever the minus charges should be on the surrounding atom. Then these the minus charges should be on oxygen. Very easily you can take. We are calling this one as oxoanions. Oxoanions mean the anions which have oxygen. What we call for this? Oxoanions. So there are 2 minus charges. No? Then 2 minus charges mean this is the basic structure around sulfur. There are 4 oxygens connected like this. Now I have to fill the bonds. There are 2 minus charges. No, Puta. Then 1 minus charge on this oxygen, other minus charge should be on this oxygen. If they are having a minus charge, they can make only 1 bond. No? But I said no. When they get minus charge, when they make bonds less than they can make. Normally, oxygen can make how many bonds? 2 bonds. So oxygen have made 1 bond. That's why they get a minus charge. Then these 2 oxygens will connect with what bonds? Double bonds. Now around sulfur, sulfur belong to which group? 16th group. 16th group na sulfur. Yeah. Here. Sulfur comes below oxygen that you can see from the periodic table. No need to by heart these things. Right? Sulfur comes here. Here sulfur maximum number of bonds. How many bonds he can make? 6 bonds. Sulfur can make up to 6 bonds. Again, only third period people are equal. Only for third period. This is okay only for what? Third period and above. Third period and above only you can say maximum number of bonds in the central atom is equal to their group number. For second period and all, everyone maximum 4 bonds only. Right? In second period and all, what is the maximum number of bonds they can make? 4 bonds only. What is the maximum number of bonds hydrogen can make? Only 1 bond. So these are very important rules. You should remember. Okay. Then SO4 2 minus will come. Then sulfur you see 1, 2, 3, 4, 5, 6, etc. That's it. Now you just fill these things. They will have this much. This oxygen will have 7 electrons. Why? It has a minus charge. Now you got some idea. I didn't teach everything completely here, but we are done with this. But I just I recalled whatever the things we have done. Okay. I hope you can understand. Understood everything? Right. We'll take a small break, right? Around 10 minutes. After that, we'll do the session. 10 minutes, I'll give a small break. Drink, eat, speak. Chutti break. Yeah. This whatever things, if you want, you write it. Huh? right? Now, okay. Now say this part. But you all will be staying for chemical calculation session, 8 o'clock. You are going? Yeah, that's it. 8 to 8:30 session. Are you staying? You're going? Right. Okay. Right. Okay. Now we'll do certain past paper question. Now these days we are doing 8 to 8:30 chemical calculation night sessions. Yeah, chemical calculation we are doing as night sessions. It was we have only one more day, right? We have only one more day to finish these things. Next week, most probably, we might finish all these unit 2 part, right? So next week we will finish most probably all the unit 2 parts. Then after that, we will start unit 3 freshly. Again, we don't take this, whatever the things we have done in the chemical calculation nights, we won't take as we have done those and those things. This is just a backup lesson, right? To improve the chemical calculations. Okay. This the students who are here, whoever here, do you know like how many the students who are in bio stream? Last week I told that, right? How many students face bio stream? How many students set for bio stream? You know, how many students at 2024 from the things UGC released? Okay, the statistic UGC released in 2024. How many students set for biology, guys? Nearly 50, right? Okay, you raised your hand, you did biology, right? Anyhow, 2024 from the number of students who did biology, there is a statistic. Okay, in that statistic, they have told, yes, this number. Mm, okay, this is the number. From the students who have done biological science is 53,381, right? Out of this, the number of students who have passed biological science, 31,152. It means 22,000 students fail biology, right? This is this is a sheet which given by University Grants Commission. Okay, these are truth data tables, and the students who face physical science is 35,996. It means math stream. Only 22,565 passed the exam, right? It means nearly 13,431 students have failed at maths. So this is the current scenario. Therefore, Buddha work well. Okay. A very big amount has failed. So work well and change your things. Okay. So just I gave this not to scare you. You should understand how serious it is. The more you work, again, the students who see for comforts, the student can remember this is completely our dedication. You are dedicating somewhat, but more than that, you need more dedication towards this. The more you dedicate, the more you work hard, more you lose your comfort. What will happen, guys? You will go to your victory, right? Remember, the people who are becoming top notch people in this, not the people who are 100% talented, the people who are working hard, who were working hard again and again, definitely they will go for top places. Some people, they are very smart. They think because they are smart, they are working less. Those people won't see even a single day. Because I have seen many students, they have got 9 A's. Actually, 9A is a curse for A levels. The students who get 9 A's, they think, we can do well. We are smart because whatever they have done in O level, they think because they are very smart now. So if they do little bit, even O level taggal, they'll get A. That is a special thing about O level. O level, if you put small effort, you can get A. But A level is not like that. Okay, although you are smart, I have seen my friends also like that. Okay, nearly in our, I can remember, more than 30 students got 9 A's. From all the students who got 9 A's, not a single one got 3 A's. Right? Then what happened? And a person who got 9 A's in A levels, he failed all three. He got 3 W's in math stream. Okay, they are talented people, not dumb people, real talented people. Again, remember, this is very serious. Therefore, don't see day and night. Don't see anything, because I appreciate most of the students, they are doing a part dedication. Some students actually they come from very far, right? Okay, you are come part a distance, you also coming from a distance, right? Actually, it's like if you're traveling more than 10 kilometers, mean actually it's a very big thing. Okay, even you have, because you guys coming after school and you have sacrificed things, right? We are appreciating. So for all these sacrifice, if you want to give a meaning, you want to work with. Remember, the success doesn't depend on the number of classes you go. Success depends on the time what you spend alone. The self-study time depends your marks. You have to spend more time on self-studying. Whatever you have done, you have to do that. We'll say, for an example, you have completed unit 1 mean. Now you have, there is a book called Pesuru. You all know Pesuru book? You don't know Pesuru book? You don't know Pesuru? If you don't know Pesuru, it's a curse, right? You should know Pesuru. Pesuru is the book. This is the Pesuru book. Or Pesuru I have written. Pesuru is the book. They have classified all the questions, all the short questions into different things. Now I will display it. No problem, although you don't have this. I can give you all the Pesuru books PDFs with answers. Right? You can use the PDF, or you can buy this. This is in Saraswati. For all the subjects, it is there. Physics there, chemistry there, right? Biology there, right? For all these subjects, they have classified the units. You don't want to search you don't want to search for questions. You have the questions already, ready-made questions, by classifying the topics. So what you have to do, you have to buy that, and you have to just do with the answers. Sometimes answers are wrong. Chuttak wrong. From 1981, the questions are there. 1981 to 2024, it means 45 years past papers. 45 years past papers mean, imagine the lot. Okay, you don't want to, at least, if you can try everything, it's best. But certain things are chuttak changed nowadays, right? Syllabus. Then, but anyhow, most of the things are correct. So you can see, and you can do at least from 2016 onwards, even you can try those things. So what you have to do, guys, when you finish a lesson, the first thing you have to do is you have to go home and you have to complete all the questions in that part. That you have to do. It means you are success. Now if you have done physics, mean physics unit 1 done, mean all the question related to unit 1 you would have completed. Don't wait until the teacher do it. So that's the difference between a successful person and an unsuccessful person. So if you want to become successful in this world, if you want a successful person in A levels, remember, guys, you have to complete all the questions, whatever you have done, right? It means, like, if you in physics, like I guess you might be doing nowadays linear motion, maybe, right? The linear motion, if you are done with something, you have to do the questions related to linear motion. Even you have to do structures, right? Okay, there are so many resources where you have reviews, you have the past papers, you have those. There are so many Google Drives are circulating among students. You have such Google Drives, a past paper collection, school paper collection. You all have those Google Drives. Got to know? Don't have. Okay, we'll share it to you. Right? There are so many Google Drives which have past paper collection. Okay, past paper reviews. So many people have made those things for all the subjects. Biology, physics, chemistry. That is in one folder. I think those are very easy to access. Right? I think there are so many teachers, papers are there. They have classified the papers, they have put those papers. There are so many things are circulating. So you should have those. Nowadays, no need to have everything in PD, no need to have as what? Rough papers. Everything nowadays has a PDF. You can't print so many things at once, but you can use the PDF and you can study. Right? You can't tell we are like ancient grandmothers and grandfathers, and you can't tell we are used to books. If there is books only, we will learn. Otherwise, we won't learn. You can't tell like that. You can use the PDF and you should be able to learn. Okay. So many things are there, Buddha. What you have to do, you have to just work like a monster. Work hard in silence. You have to just keep on working. And if you are students, what you have to do, you should go classes. That's true. But remember, at the same time, you should allocate more time to study alone. You should have more amount of time. Every day you should have a target. This much of work I will complete here. Don't put timetables. Morning 8 I will brush. Morning 8:30 I will go to washroom. No. Don't put such timetables. What you have to do, You have to just put, right? To tomorrow's target, I have this much of self-study timing. I have classes and all. Classes don't consider as you are studying. No? Classes, what you do, you gain your knowledge, you fill your knowledge. There, what you have to do, self-study is only you practice the knowledge what you have gained. Now you understand things in the classes, and you have to work alone to make it patta thorough. Right? Remember, A level is more difficult. Otherwise, this much of students won't fail. Right? Don't think the scenarios has only for maths and science stream. Even commerce stream, art stream, everything like this. Like 20,000 fail, 30,000 fail. Art stream more than 30,000 fail. Right? Commerce stream nearly 19,000 fail. Okay, this is the fate of Sri Lanka. Right? Most students they fail not because they are not having talents, because they are negligence. Remember, guys. Okay, if you want to succeed this, please work properly. Right? Check what is your mistakes. If you don't understand your mistakes, remember, definitely you won't succeed. Right? It means you have to select, always I'm telling, you have to go only for one teacher. Right? That is very important. You have to go only for one teacher. Okay, it means that teacher, whatever that teacher doing, you should understand properly. Right? You should understand everything properly. Yeah, if you understand only a little bit properly, other part you don't understand, there is a problem. You should understand everything properly. Then you can rely on that teacher. Again, the best of because if you go 2 classes, what will happen? You will lose your self-studying time. You should have self-studies time. Self-studying time is must, right? Whether you can do self-studies, then other thing is you can put more hard work effectively. Everyone are studying. They are studying night and day and night. But the thing is, results are not produced. On these students, they didn't go for classes. Everyone went for classes. At least 99% went for classes. Everyone went near good teachers. Everyone did past papers. Everyone did questions. But still this much of fail. Right? Doesn't mean they are dumb because they chose math science stream, because they got some confident, I can do that kind of confident thinking only they came here. They thought we can do that. Remember, guys, your negligence can cause a huge problem to your life. Right? So the main part of A level is your self-study time. Right? Remember that. So if you achieve 3 years, what will you get? Don't think only local universities. You will get even foreign university scholarships if you apply through channels. There are so many things, so many university applications are there. Nowadays, everything is circulating because nowadays social media. Nowadays, you get so many applications from so many foreign universities. They check their A levels, and if you have such results, they give you 100% free scholarship for this. Sometimes you can go for world top 10 universities if you have good results. Then they will give entrance exam. If you pass that exam, so they will give you full scholarship. You don't want to spend a penny for that. Okay, they will give you completely free. Okay, so there are so many chances are there. Okay, everything comes under your name. Now what I say I'm Dr. Shuhail Shukry. So doctor comes in front of my name. Right? Then whatever the studies I have done, it comes under my name. It don't come to you. Right? Whatever you do, it will come under your name. It's 100% yours. Right? So whatever you do now, it depends your entire future. Right? So please work hard, work properly. It's okay? Right. Now I just because I thought without motivation we can do the sessions, but students need motivation. Without motivating students, they can't do. Right? Some people think, he's motivating, always he's motivating. So I stopped motivating for some days. Right? Then that happened. Then after that I realized no, motivation is must. Right? Otherwise student will fall. They don't know what to do. They go out of track. Okay? Right. Then we'll go for the past paper questions. We'll see. Okay. I'll exit these things, right? And I'll put the USB. If I put the USB here, from where can I read this? File manager. This is my drive, no? And in this, I can choose chemistry. Here, this is Pesru. These are all Pesru books. Here, from all these 4 PDF, the entire chemistry syllabus is there. Classified questions. So I'll select this now. We'll open that. WPS office, right? What can we open this? Right. It came. You can see, right? I can zoom it, right? Right. Nice. Then again, now you will see for an example. This space, this is the way how they have classified. See, atomic structure bit from the things what they have can go. Yeah, in why it's not coming? Why? But it's not coming this side. Can't I move this? Can like this. Have to have full finger, right? Anyhow, right. It's okay. Anyhow, you can see this atomic structure bit. You can see nucleus charge of oxygen is scale. From 1981, you have this. You didn't know this, no? It means you are not into A levels, guys. If you don't know about this, it means you are very far behind from A levels because remember, everyone are working like monsters for the exam, right? You know, I said no, like 30,000 pass scale. You know how many people they took to university for all the courses? Only 9,000. Only 9,967. Nearly 10,000 people only they took out of those 31,000 also. Out of that 31,000, more than 20,000 they will put out. They won't take to the university. So understand the competition. Can you understand? But don't have jealous for others. You work like a monster. When someone's studying, don't look at them. Oh, something should happen for this guy. Okay, don't hide the books. Don't do Jara works, right? Or what you have to do, you have to see them and you get more. This bug also working, right? Then we also should work. Don't go to hide their books. Those are not good things, right? I have seen so many people, they throw others' books. They hide their books. Right? They damage them. Right? Remember, you can't destroy knowledge. Hurry. Now, anyhow, yeah, it's not going up. No. Now, how can I send it up? Right now, we'll see the questions related to the things what we have done here, right? Come here. This periodic table. No? Yeah. I had to go for unit 2. Unit 2 is this page 18. This is still this is all page above, no? I think. Right, beautiful. Right. These things are okay. The heading is you can see covalent bonds, geometrical shapes, and polarity. Right? Still I didn't do polarity and all, right? No problem. We'll see. Now we'll think see this. Okay. The shape of BeCl2 molecule. I guess even online students can see this, right? Right. The shape of the BeCl2 molecule. Already you know. Already you know the answer, no? What is the answer? How to annotate? Annotation. Right. Okay. Where is the pen? Pen is there, right? Where's the eraser? What is this? Okay. Where's the eraser? Okay. These things also getting erased, huh? There are pen, no? There is eraser. All right. I didn't know. I haven't used this. What is this then? Quickly draw highlights. This is normal pen, right? I have colors, no? Right. Nice. Okay. Now, no, but first time I am using this, right? I never used by using a pen, right? All right. So it's nice. It's easy to observe, right? Right. Now see this. This is a directly question from 1981. Okay. I think you haven't thought about coming to Earth at this time, right? Hurry. Then there is this BeCl2 molecule already we drew both. How you get Be? What's happening here? Will it disappear? BeCl2. Right? This is BeCl2. Then this is only what is this? This BeCl2, guys. Right? So in the BeCl2, what will happen? Okay, you can see this is a linear shape. BeCl2 linear shape already you know. Right? Okay. Then we'll go to the next one. The bonding between two atoms is said to be ionic. Now we didn't do that. Right, we'll go for this one. How to move this now? Different time, different place. I don't know. We don't think I'm like an old fellow, like don't know this. Huh? What place? There. Right, okay. Anyhow, we'll go for this. Come for this. The number of pairs valence electrons around the central atom of BCl3. You all try. You all tell me the answer. The number of pairs valence electrons around the central atom of BCl3. Valence electrons we didn't do, no? But still you can tell. BCl3. Central atom of BCl3. So BCl3, how to draw it? You can draw like this, no? B, chlorine. This BCl3. What is the shape of BCl3, guys? What is this? Come on, speak this. What is the shape? Trigonal planar. Excellent. Trigonal planar. So how many valence electrons are there around this? How many electrons are there? Right? This is one, this is one. This is one, this is one, this is one, this is one. So how many electrons are there around the boron? There are, answer is 6 electrons are there, but they have a number of pairs. So how many pairs are there? 3 pairs. Okay? Right. Come for this one, guys. BF3 molecule has a BF3, same thing. BF3 means instead of chlorine, you have to put now. Instead of fluorine, you can put but chlorine. Instead of fluorine, you can put chlorine. Okay. Instead of fluorine, you can put chlorine. Sorry. Right. Now in BF3 is this. This is BF3. Okay. Can online students see this? Online students. Okay. Right? Okay. Now see this, guys. This is BF3. In this BF3, right? This BF3. They are saying BF3 molecule has a similar shape to ammonia. How you draw ammonia? Ammonia, nitrogen belong to which group? Putta? Fifth group, no? You just see the periodic table. That's why I said you should have a periodic table. Then you can check it easily. Nitrogen belong to fifth group, no? Then around nitrogen, when nitrogen connect for 3 hydrogens like this, when nitrogen connected for 3 hydrogens like this, what will happen, guys? Nitrogen have 5 electrons, no? Then 1, 2, 3, 4, 5. Then 5 electron will be like this, no? Then this is the shape of ammonia. Okay? This is the shape of ammonia. Ammonia you will draw like this. Okay? Later part you can see how to draw this. Then you should know to draw the Lewis structures. Now I gave you a easy pattern to draw this. That you should know the periods and group to get this. So in this ammonia, guys, can you see what is this shape? Takal, tell me the shape. What is the molecular shape? Come on, guys. What is the molecular shape? What is the molecular shape? What is the molecular shape? Correct. Tell. Pyramidal, right? What is the molecular shape? Pyramidal. Why? You forgot everything after the advice, right? What is this? See how many repulsion units? 1, 2, 3, 4. 4 repulsion units mean what is the shape? Tetrahedral. So 4 repulsion units, they have removed 1 mean that become pyramidal. Got the point? So they have said BF3 molecule has a similar shape to NH3. True or false? False. Right? They both different shapes. BF3 is what shape? Trigonal planar. This one, pyramidal. They have both ammonia and BF3 have equal number of pairs of bonded electrons. That is true, no? Equal pair of bonded electrons, right? These people are having 6 bonded electrons. These people are having how many bonded electrons? 6 electrons. That is true. First one false, second one true. Mean which one is the answer? Answer is fourth one, right? You all know that, right? You people, you know. First one wrong, second one correct. Mean answer is fourth one. You all know. You don't know these patterns. You all in A level, right? You don't know these things. These things only I explained on the first day itself. How to answer a question, babe. Right? Again, you know there are some questions like this in A level. Statement question skill, do you know? Do you know 41 to 50th question will under statement questions? Then you don't know how to get the answer for this. Again, now I don't explain. Now, this is wrong, this is correct, mean answer is fourth one. There is a pattern to get these answers. Right, I will explain later. Now, you just understand. This is wrong. Again, answer comes like this. How? If first one is correct, second one is correct, answer is 1. Again, first one is correct, second one is correct, second one explains, first one mean, it explains mean answer is 1. First one correct, second one correct, first one and second one no connection mean answer is 2. First one correct, second one wrong mean answer is 3. First one wrong, second one correct mean answer is 4. Both are wrong mean answer is 5. Because you have MCQ sheet to answer from 5 questions. No? Okay, you have 5 choices. Out of 5, you have to cross the paper. For statement questions, this is the way how you should answer. Remember that. No? If you don't know, don't tell her don't know. Now you all, I guess, when did you do O levels, guys? March. Now what is this month? September. Now how many months have gone? 6 months. Now how many months you are A level students? 6 months. What are you all in A level for 6 months, guys? Half a year. Can you understand? You're old people now. Because next batch is also going to come for A levels. You're also going to be senior in A levels. So understand, telling I don't know these things is not a healthy thing, right? Anyhow, because when we do the things here itself, you get a very good thing. In which atom will the removal of an electron will be most difficult? We will discuss later. Which one of the following molecules has a pyramidal shape? Answer already we have. What is the answer? Already we got NH3, ammonia. Already we have that. See, always they ask the same type of question. Water, you know, H2O. Water, I'll draw these things and I'll show you. Tell me the shapes. Huh? Water. This is water. What is the shape of this, guys? Water? Yes, very good. Water angular. Ammonia, okay. Beryllium chloride already you know. No? What is the answer? Beryllium chloride? Answer is linear. Carbon tetrachloride mean tetra mean 4. Carbon tetrachloride mean CCl4. This is only carbon tetrachloride. Okay, this is only carbon tetrachloride. What is the shape of this carbon tetrachloride? Tetrahedral. Very good. Okay. Boron trichloride mean BCl3. BCl3, what is the shape, guys? Come on, speak. BCl3, trigonal planar. Okay, you should know these things, right? Okay. The shape of the H2S molecule. H2S mean like H2O. This is H2S. H2O again H2S. Oxygen and sulfur belong to the same group, no? Then H2S is what? Like this, no? Sulfur, hydrogen, hydrogen. Like this. Okay. What is the shape? Angular. Are these things difficult? See, A level is easy. Easy, no? Yes. No? Easy, no? But are you okay? Right. Got scared? Right. Okay. Covalent nature is highest. Those things I have explained. Have explained? Can remember? Can't remember. Right. Yeah, was fail check. Because today's topic, this is not related to today's topic, no? Right. Okay. H3O plus is planar. You know what is planar, right? Planar mean? Again, they are telling they are in the same plan. Same line. Do you know how to draw H3O plus? How many hydrogens are there? 3 hydrogen. 3 hydrogens surrounded by whom? Oxygen. Don't get scared. I gave a way how to get this thing. There are 3 hydrogens, no guys. Then 3 hydrogens mean hydrogen valency is 1, no 3 hydrogen mean valency altogether 3. Oxygen's valency is how much normally? 2. Then put 2. Plus mean with the plus charge add 1. 3, 2, 5, 5 and 1, 6. Then how many bonds are there? Number of bonds? The number of bonds will be 3. There are 3 bonds in this. 3 bonds mean around oxygen, 1 hydrogen, 1 hydrogen, 1 hydrogen. I gave a method to put plus minus things, no? Then around hydrogen, how we 1 bonds, there's how can. Around oxygen, what is the normal valency of oxygen? Oxygen's valency is 2, but they have made 3 bonds. Again, they have made 1 extra than that, no? That's why this become plus. Very simple. Therefore, H3O plus is a planar. What is the shape of H3O plus? Trigonal planar. Then answer is true. There are 3 OH bonds in H3O plus. Answer is true. Okay. Then just because 3 OH bonds are in H3O plus, it means, does it explain, second one explain the first one? Again, H3O become planar not because it's having 3 OH bonds, no? Right? Again, OH bonds are 3, that is okay. But what they have to tell there? There are only 3 VSCPR units, right? Therefore, here we can't take, there are 3 OH bonds because there's 3 OH bonds, it become planar kela, we don't take. Therefore, answer we have to go as 2 kela we are going. Again, they didn't explain why this is plan. This is plan according to VSCPR theory. If they have told like this, there are 3 sigma bonds in H3O plus mean, we can go this one. So can you understand? Okay, you see the shape of the cation species PCl4 plus. PCl4 mean I said phosphorus belong to which group, guys? Which period? Third period. Third period mean do we count number of bonds? No. We just put the least electronegative element. Out of phosphorus and chlorine, who is the least electronegative element? Phosphorus. Then around phosphorus, how many chlorines are attached? I said these get attached with their valency. Chlorine's valency is 1 because 17th group. Then how many chlorines get attached? 4 chlorines get attached here. 1, 2, 3, 4. Then phosphorus, how many electrons it can have? How many electrons it should have? 5 electrons, no? It should have 5 electrons. Then, but it has only how many electrons? 1, 2, 3, 4 electrons. But it should make a plus, no? Because it should make a plus, what should do? I have to put I can send that electron and I can put a plus charge on phosphorus. This is the way you have to draw this. Either PCl4 plus is this. What is the shape of this? Huh? Tetrahedral. Is it there? No, then what is the answer? Nice, ne? Very nice, no? Interesting, no? Right. So, again, when we are doing with the past paper question, you get more confident. Oh, whatever we have done, we can answer. That is only important. So, if you didn't know about these things, that is a very big problem. You should know about this. Okay, we will share everything. I already shared the PDF in our group. Okay, I think you can get this PDF from our office number, right? Again, whoever interested, this is our office number. I guess you have this 390, 450, and 6. And if any student, if you join, guys, don't worry, you will get all the recordings, whatever we have done up to date. We have everything, whatever we have done up to date. We will give you everything, and we will give you a work plan also how to watch that. Right? Again, the students who have missed these things, again, we will give you definitely what are the things you have to watch first. Those things also we will give you. So I hope you can understand everything. Okay, now we have to start our CCN, chemical calculation nights. So if you want anything, Putta, you can message this number and you can get the things done. Okay. Right. Then whoever going now, you all can go. CCN ekata. We'll start the CCN. Right. Putta, directly doing things on the board like this, I guess, very effective. No? It's like nice, no? Right. Then I have to take this one off. Okay. Then what I can do? Can I hope I can save these things, no? We'll save it after the class, no? මෙතන save කරන්න ඕනේ නැහැ. We'll save here itself. Okay. Okay. Then we'll go back. Okay. I have to eject this. How can I eject? I can go to home. Can I eject this? Can't eject this, no? Can't eject this, no? Using this? Can't eject this. Okay. Okay. Right. Bye. Okay. That's it. So the students who are joining CCN, you all can join. No? Right. Guys, I sent the tute in the chat box. Do you want to tell